Hey everyone. I hope everyone is doing well and healthy. But I just wanted to go over a few questions that I've had for ISA number 1. Every day I plan on making a video of questions that I'm seeing and address those, and then that everyone can come back and listen to the video and see if they understand, or if you have more questions, please send them to me. So I have 2 screens pulled up that you can see, and I want to go through these ISA questions. So the first one is said, which sentence best describes what most likely caused the loose soil? And the prompt, it says students observed 2 hills, A and B. After a heavy rainstorm, the students observed that hill A has more loose soil at the bottom than hill B. So A has this loose soil, and they're asking you, why do you think that? So is it the first one? It says hill A has fewer plants than B. So you got to think back to what we learned, and would fewer plants cause loose soil or not? And then hill A erodes more slowly than hill B. And you got to go back up and think hill A erodes. It said that there's more loose soil at the bottom. And then hill A has a slope, not as steep as hill B. And hill A receives less average rainfall than hill B, which they did not talk about rainfall at all. So that one I'll tell you, that one is not it, like at all. And if you look through these 3, you have to think which one would cause erosion, which one would cause that more loose soil. So think back to things that keep the soil in place, and then you will have your answer. I'm not going to give you the answer yet, but I would like you to take that into consideration. The next one is about the chemical change, and for this one, I'm going to play the video and then make notes at the same time so that we can go back and look at the notes to try to figure out our answer. So let me play this. Remember, she talks really fast, so sometimes you might have to pause it.
You know what's a really great way to learn about science? Baking. After all, baking is pretty much just chemistry, and chemistry is the science of different kinds of matter, and how that matter can change. Sure, some of the equipment used in baking and in chemistry isn't quite the same, but both baking and chemistry require time measuring, and both of them result in the formation of a mixture. For example, you could matter like eggs, milk, flour, and sugar into a tasty dessert. Now, you already know that a mixture is anything made by combining 2 or more different things. And some kinds of mixtures, like the fruit salad we had at our picnic, can be separated back into the substances that made them. But that's not true about all mixtures. Sometimes mixing things together makes a whole new substance. We call this chemical change. But what is a chemical change?
So I'm going to stop it there. The main reason I uploaded this video is because this week we were initially going to start learning about chemical change and physical change. So this question went along with chemical change that we haven't learned yet, but I wanted you to watch this to kind of get an idea about what is a chemical change, what makes it different from a physical change. So there are times that you mix things and it's only a physical change. It could be changed back, or it's not making something new. But a chemical change is making something totally new, and there are things that you can look for that will give you clues that it's a chemical change, and that's what she goes over, and that's kind of what the question is asking. If the observations that you made with this new substance, what would make it that it was a chemical change, that a new substance was produced?
A chemical change is a change that occurs when the particles that make up 2 or more substances are rearranged to form a new substance. Unlike the mixtures from our picnic, chemical changes usually can't be undone. Let's observe an example of a chemical change. Observe, people. We're not trying this at home. When we observe a lit match, we see that the match burns. As it burns, it changes into burned wood and ash. We can't change this ash back into a match, so burning is an example of a chemical change that can't be undone. wait, there's more. Chemical changes often make matter change color, like the blackened remains of a match. Sometimes chemical changes make smells or release light or gases, and lots of chemical changes require either the giving off or taking in of heat. A burning match gives off light, smoke, and heat. All of these are evidence that when we look at a burning match, we're looking at a chemical change. Now we can do a simple investigation to show some chemical changes can use seriously yummy.
Okay, so I'm going to stop it there because mainly I have all the notes that I need of what observations will show me a chemical change. So like burning, changing color, making smells, releasing light, releasing gas, and taking in or giving heat. So our question said, if students mix an unknown white powder with an unknown clear solution, select 3 observations that might indicate that a new substance is produced. So the first option is bubbles are produced. And if you keep watching the video, it's going to tell you about a cake being made. And they said that there are clues that gases were released, which would be like bubbles in a way, because there's little tiny holes in that cake. So when there are holes in the cake, then that shows that there were gases released. So when bubbles are produced, that would be a gas that's released. So you can kind of, I'm going to just put a star by there because that's one of it then, because that's showing if bubbles are produced, then that means it's releasing a gas. So that's a good check mark. Okay, that's on our list. All powder dissolves. So that means if we would take, like, let's just say salt and water, and we would stir it up, that salt's going to dissolve. However, think about this. Can we get it back to just salt and then just water? We've talked about this in class about how we could separate salt and water through evaporation. So think about if that would be something that is always a change, or if it could be changed back even though the powder dissolves. And then the temperature increases. So that's something that we have on our list here, taking in or giving heat. So if the temperature increases, that means it's taking in or giving. And then the solution changes color. Well, right over here, we made in our notes, change of color is evidence that there is a chemical change. And then the volume of liquid increases. We know by the conservation of matter that we've learned about that your volume is not going to increase. It's always going to be the same. It's going to be the same that it was before and after. And so keep that in mind when you're answering those. So you need to choose 3 of those that would show that a new substance is being produced. And then we'll get to the very last one. And mainly think about if you set a cup of ice out on a hot day, and you have you can have ice water in it, that would be okay. But it's asking you how would the formations of water droplets be described in the model? And mainly the water droplets are on the outside of the cup, and they're asking you how would that happen? And so the options are ice in a cup makes water droplets form on the outer surface more slowly. And then invisible particles of water in the air. Sorry, my child decided to join me. Katie, would you like to say hi to my classroom? No, you're going to be shy.
Can you charge my tablet?
I'll charge your tablet later, but I have to finish this video. I'm teaching right now. Okay? Okay. All right. Anyways, so the next one, invisible particles of water in the air run into the cold outer surface and form droplets. Small droplets of water escape through the top of the cup and land on the outer surface. And particles of water shrink when cold and move through tiny holes in the cup in the outer surface. So I'm going to give you one hint here. Liquid cannot go through those solid cups. So this last one here, that's not your answer. That is not going to happen. It's not going to go through the cup. But we have to figure out where is that water from the outside of the cup coming from? I will give you a huge hint or something to think about. Think about our water cycle. How would we get water droplets, say, on the mirror in the bathroom when we're in the shower? The water droplets don't go straight from the shower to the mirror. There's some kind of change there that's happening. So those will give you some ideas, and shoot me any questions that you have, and I will make any explanations that you need. But remember, you can keep doing this over and over and over again until you do get it right. And if you still don't understand it, please send me a message. I can either type you the answer or I can make another video, and we can always go from there. So I hope everyone's having a great day. I hope you got to sleep in, but now you're doing your work, so that's awesome. And hopefully it warms up a little bit so everyone can get outside and get some fresh air. All right, everyone, I will talk to you soon.